this is Lori and welcome to my series on the Pico W. This is part 13 in the Exploring LED Displays episodes. We're going to continue working with the 8-digit 7-segment display using the MAX7219 driver chip. And now we'll be using the driver chip without a library. Right, to use the driver chip, we're going to have to spend some time with the data sheet. And data sheets, if you don't have a background in them or in electrical engineering, I think they can be a little challenging for newcomers. I certainly didn't understand all the conventions that are used in data sheets. And so I'm very thankful for the help that I got from Ralph Bacon and Julie and Alette, where they leveraged using this data sheet with Arduinos and controlling the 8-digit 7-segment displays. Like I said, I watched some of these videos. I think they were really helpful, and they helped me bridge the gap of what I just didn't understand when I'm staring at these data sheets. Now, this is the front page here of the data sheet. I happened to get this one off of DigiKey because they do sell this chip individually. So I found the data sheet there, and it looks like it was a pretty up-to-date one. And it tells you a little bit about what the device can do. And it also tells us that we'll be using SPI as our communication to the chip. And it tells us some other things like there's a binary coded decimal decoder built into this. There's various decode, no decode, digit selection. A lot of things that you have to read maybe multiple times so you can figure out what the point of them is. But yeah, so this is just the basic front page and tells us a little bit about this driver chip and how to get started with it. All right, to control this chip, we're going to need to set up SPI just like we did for the libraries. So we'll do the same sort of thing here. We'll indicate our data in, our clock pin, and our chip select pin. Using appropriate SPI pins for our Pico here for data in and clock. And we'll set up an SPI bus just like we did again for the library. But now we want to send our own commands to the chip, and table 1 gives us the format that we should use for that. And so it's a 16 bits that we want to send in. And this was one of the places that I didn't understand the conventions of data sheets. But when you see a big X here, that means you can send or set this to anything, but the convention is to set it to 0. So they're just not being used in this case. Then we need to send in our address in the next 4 bits, and then the data follows in the 8 bits here at the end of this table. So that's the command. So you can see we're going to send in an address and then data that will give the command to that address. Now, table 2 tells us what are all the addresses that we can address. And so there's a no op, and we'll talk about that in a little bit. And then there's digits 0 through 7. So those are our 8 digits. So that's how we tell the digits what to display. So these are the addresses that we'll use for that. Notice they go 1 through 8. So that makes sense. Then there's a decode mode, which we'll talk about also. Intensity, you probably guessed that's to do with how bright the LED display will be. Scan limit we'll also talk about. And there's a shutdown address and a display test address that we can send commands to. So those are all our register addresses that we can use. Now down here I have a simple example, and again we'll talk about decode mode in a little bit, but this is the command if I wanted to write a number 3 into digit 2. So digit 2 here in the table, I would look up, I say, okay, I want to go to digit 2. Here's the address that I want to send it to. So there we go. And then this is the data that I need to send to produce a 3 in digit 2. And you'll notice that I had to set the chip select pin to low or 0, send the command with the SPI write function, because that's the way we would communicate using MicroPython to the SPI bus. And then we set the chip select pin high again. So indicating when we're starting to send a command, then we're finished sending the command. So that's how we need, that's kind of the format we need to send commands to the chip. All right, the first two registers we're going to talk about are the shutdown and the decode mode. In the shutdown, you can see in table 3 here, and I'm just kind of working through the datasheet table by table. Shutdown mode, you can see here, is this address, and it tells you here's the data that you need, and again here's all these X's, and again if you didn't understand that you should just basically send in zeros for this, then you're sitting there going, what are these X's? I don't understand. Anyway, so if you want it to be shut down, well then you send all zeros, and if you want it to be a normal operation in the last place, D0, you send a 1. So if we want to set it to normal operation, in other words, activate it or enable it, then we'll send in this command using SPI write and kind of flipping our chip select pin. And so we'll call that address, and notice again, here's the X, but I'm replacing that with a 0 and then the letter C. So that's the correct address for shutdown. And then I'm going to send it the 1 in the D0 place using this hexadecimal value. So that sets it into normal operation. Now decode mode, that's where there's some built-in characters into the chip, and we'll talk about those in just a minute. But if we want to use those built-in character set, then we need to turn on the decode mode. And we can choose whether we want the decode mode turned on for certain digits and not for others. So you can see here the table 4 shows us that we can have the decode mode turned off, and so then we would send this command. If we wanted to enable it for all the digits, we'd send in this command, and if we wanted to enable it for different numbers, you can get the picture of what you would do with these couple of examples. I think mostly it's either going to be all or nothing for most folks. So in this case, this command is an example of setting on the decode mode for all 8 digits. So again, sending in the correct address for that one, and you can see it up here again, replacing the X with the 0, and then I want to turn it on for all the digits, so I'll send FF and hex there, and that will turn on decode mode for all the digits. Alright, so this is the decode mode fonts that are built in. It's not extensive. Table 5 shows us what our choices are. If we have decode mode on, this is how we can send in these characters. So obviously we can send in 0 through 9, the numbers. We can send in a dash, and we can send in the letters that would spell out help. So H-E-L-P, and we can also send in a blank. So it shows us what we need to send in that command, what data we need to send in. And you can see that it's just the last 4 bits that need to be addressed. The next 3 bits we could send in anything, and by default we would send in zeros. And then the D7 position is what controls the decimal point. So if we send a 1 in the D7, the decimal point's going to get turned on. And if we send a 0 in the D7, it will not be turned on. And then this just shows us, if you remember the layout of a 7-segment display, remember there's decimal points, and then the segments are labeled A through G. This just shows us what segments are going to be on if we send this data to a digit. All right, so I have several examples over here of how we would do that. So here's how we could write the number 1 in digit 0. So the digit 0 it has the address 1, and we could send in a 1 just like we have here. And we could put 2 in digit 1, so a 2 and 2, a 3 and 3. And here's where we could, just showing a difference of how do we send in the decimal point. Well, here you can see this would be the hex code that would give us a decimal point with the number 4 in the digit number 3. And then here's how we could blank out the next digit, for example. We could give the 0F data, and that would just create a blank. And you need to do that because there are stray signals on the pins, and so if you don't blank things out when you're putting other data on there, you will get ghosted letters and random bits showing up in other digits. So you do have to make sure you kind of blank out places that you're not sending data to. So you often have to send blanks to other digits to make sure just the digits that you want to show are showing and no extra random bits are being turned on. If we don't want to use those built-in fonts, then we have to turn off the decode mode for all the digits. So this is an example of sending a command that would turn the decode mode off for all 8 digits. And now how we would send in data to a digit, for example, is we'd look at the map that we have for our segment display with the segments labeled A, B, C, D, E, F, and G, and the decimal point, just like we've seen many times in this series. And this is the format of the data. So the decimal point comes first, then segment A, all the way up to segment G. So if I wanted to make a degree symbol in digit 0, I would send in the address for digit 0, that's 1. And then I tend to use binary for this when I'm laying this out, because it's a little simpler for me to say, oh, I want A and B on, and then F and G on, and everything else off. So that would send in a degree symbol. And then, as I said before, when you send something like that in and you want to display it, you really need to blank out everything else. So all the other digits, if I want to send in a blank for them, then I would just loop through them and send in blanks for all the other digits. So this is an example of how I could do that using a little for loop. So hopefully this is starting to maybe get a little repetitive, but I'll work my way through the last of these registers. Intensity is one you probably want to be able to control, and you can see here that table 7 goes through how to control the intensity of the LED display. So we'll use this address, and then here's all the different commands that we could send in. And you can see it's just a matter of, with the 7219, what level of brightness we want. So looks like we got about 16 different levels, and here's the hex codes that we would send in. So if we wanted full brightness here, then we would send in this command to the intensity address. So pretty simple on that one. Now, scan limit is how many of the digits do we want enabled on the display. We have 8 of them, but we don't have to have all of them enabled. So for example, if you know all your data is only going to be in the first 4 digits, you can enable just the first 4 and not have the other ones even addressable. So that's what the scan limit does, and you can see here's the address for the scan limit. And I again think most people are probably just going to have all the digits enabled, but I guess there could be situations where it might be simpler not to have them enabled, so you don't have to send blanks, I guess. Not sure if I've tried that or not, but anyways, yeah. So in general, I've always turned them all on because I wanted access to them. And but by default, I think it only enables when you turn it on the first time. Only the first digit is enabled. So you do have to send this when you initiate your program. You're going to want to make sure you enable the number of digits you want to use. And so here's an example of enabling all the digits. So I'll just send in the 07 in hex, and I address the 0B. I send it to the 0B address. So that's how I get the digits enabled. And if you don't do that, you won't be able to you won't be able to use them all, because I think it defaults to this one, if I'm remembering correctly. All right, the display test register allows us to test all the LEDs. If we want to do that, we would send it a 1. So here's an example of sending to the test, the display test register, a 1, and then that should turn all the LEDs on. So I'll put a little sleep in there so we have a chance to see that, and then we can turn it off and put it into normal operation using this command. All right, so the whole reason why I spent all this time learning how to use this chip was because I wanted to cascade two of them, and the library I found it seemed like it wasn't doing it quite right. And I think this is the place where it might have gone wrong, was it wasn't quite addressing the multiple displays in quite the right way. So it shows that it's pretty easy to hook these up, and they're definitely intended to be cascaded. There's a data in and a data out, and you just link them up together. So you can see here, here's the data in, and then the data out goes to the data in of the second one. So, and it's designed to line up. I keep looking over here, but that's where I have the setup. And you can read this here. It tells a little bit about what we need to do, but the basics are that as you send a command to one of the two displays, you need to send a no-op command at the same time. So you tell the second display, don't pay attention to this other command that I'm sending, for example, to the first one. Second one, don't pay attention to that. Don't do anything. And then if you want to go the other way, you switch it around. And if you want to go the second, you want to give some commands to the second display, you tell the first display, don't do anything. I'm sending a command to the second display. So I wrote a little function to enable that for two displays. Obviously, if you wanted to make a library that was nice, you would program this so that it would handle multiple displays. Again, I was just getting started, so I needed only two displays, so I wrote it this way. Maybe at some point I'll put together a full library. I think I have the skill set to do it now. But this function got me to where I needed to be to do the program I wanted to write. So in the send command, you'll notice I give a register address for the first, and then the data for the first, and then you can give the address, register address for the second, and a command for the second. So almost all the time I'm going to send a no-op to one of them and a command to the other, and this is how I did it in my final program. Well, that finally gets us through the information in the datasheet. I hope you found it helpful. I'm sure if you're actually trying to do some of this yourself, this is the kind of thing that I found helpful. And if my explanation isn't that helpful, I would definitely recommend watching the videos by Ralph Bacon. Even though it's for an Arduino, I do think he did a really excellent job, and it made it possible for me to understand this, at least to this level. Well, let's get on and start doing some programming in MicroPython and getting this display going. All right, let's try a really basic program and send some commands to our display. I only have one display hooked up right now, just one of them, and we'll just try to send some of the simple commands that we've discussed. We'll import from machine, pin and SPI, and we'll also import the time library. We'll set up our pins and our SPI bus as we discussed in the slides, and we'll set the chip select pin to high to start. Then we'll write a command. Let's turn on and try the test. So we'll turn it on, so that should turn on all of the 64 LEDs in the display. And we'll sleep for a couple seconds so we can look at that, and then we'll turn it off, and then we'll put the display in normal operation. We'll enable all the digits, and we'll go to full brightness and turn on the decode mode for all 8 digits. So these are all kind of initialization commands to get the display working the way we want it to. Then we're going to write some numbers to the display. So let's write a 1 in the first position, let's write a 2 in the second, a 3 in the third, and in the fourth we'll write a decimal point too. So you can see we're going to add the 8 here in our hexadecimal code to make sure we get a 1 in that most significant bit position. Then we'll blank out the other 4 digits. So we'll send blanks to those, and we'll sleep for 5 seconds. Then we'll switch to the decode mode. We'll turn it off, and we'll do that for all 8 digits. And we'll put our degree symbol up, and we'll blank out all the other digits. and we'll sleep for 5 seconds, and then we'll go into shutdown mode and we'll basically turn the display off. Alright, so hopefully this will go. Let's take a look. There we go, there's the test mode. There's our digits. There's our degree symbol. And it turned off. Yeah, so okay, it's working. We've figured out how to use this display. In our second program, we'll work with 2 displays. And I have them connected up here. So the data out pin for this display connects into the data in pin for this display, just like I showed in the previous episode. So let's try sending some basic commands to these 2 displays. We'll do the setup like we always have. We'll use the function we described previously in the slides. So if we want to send information to the 2 displays, we send first to the furthest one down the chain and then to the next one. So we'll do address 2 and value 2 first, and then address 1 and value 1 last. And that'll send the 2 commands in, and one of them will always have as a no op, depending on which display we're actually trying to send a command to. And then I made a little function to clear out the display. So we'll clear out the first display, and then we'll clear out the second display. Then we'll just sort of get the displays all set up. So we'll turn off the test command. We'll make sure we're in normal operation. May not have to do this every time, but I just put it in here to make sure it's not in that mode. Normal operation, enable all the digits, the brightness commands, and turn on the decode mode for all digits. And then we'll use our new function to clear out the display. And we'll put a 1 on the second display in digit 0, a 2 in digit 1 on the second display, then a 3 in digit 0 on the first display, and a 4 in digit 1 on the first display. We'll sleep 5 seconds, take a look at that, and clear everything out. And then here in the try and accept part of the program, we'll just do a simple counter that will go from 0 to 9 on the first display in digit 0. So you can see how we would make that happen. All right, so let's run this. Hopefully it'll work. Yeah, there's our 4, 3, 2, 1, all in the proper places. And here comes our counter, and it's in the right place. And we're not getting any kind of ghosting on the second cascaded display. So I think we're sending the no ops correctly. So I think we've got that part of it figured out. All right, in the third program, we'll just try to make this a little more formal and maybe a step towards creating our own library, but not the whole thing. So just trying to operate a little more efficiently and a lot less magic numbery, I guess, is making sure everything's well defined. So most of the libraries you see are very clear about defining the registers using some labels, so I thought that would be a good idea. So I set those up ahead of time, so maybe it's a little easier to read the commands in the program. So I did all of those set up here. And then I also created my own character map. I wanted to be able to use the whole alphabet because when I do my launch codes, there's letters in there as well. And so I borrowed this from this particular library. It was one of the libraries that would run an 8-digit 7-segment display using the MAX7219, but remember it didn't seem to have any functionality for cascading, at least what I could see of it. So I created this dictionary for making all the letters of the alphabet and some symbols too. I made a few refinements to some of the symbols, I think. And then I made a little function to get characters from this dictionary. And if we couldn't find the character, if somebody typed in a character that didn't make sense, then we'd just get a blank back. So I think that is a nice little function to have. Then I had a global variable here, or overall variable, just saying whether we want decoding on or not. And and you'll see why I wanted that. But I think in general, most of the time you're going to use this, you're either going to want the decode on or you're not going to want the decode on. And I don't think you're necessarily going to want some digits with the decode and some digits without, but you certainly can run it that way, and then you wouldn't use this code. All right, our send command and our blanking function, and you can see if I have decode, then I would blank in different ways depending on whether the decode was on or not on. And you can see starting to use the register, the names, the variable names for the register addresses here. So I think that's it makes it a little easier to see, no ops and that sort of thing. Then I made an initialization function that just goes through and make sure that the test is off, that we're in normal operation, that we've enabled all the digits. We've set the intensity. Again, I set it to 5 this time. I've tried a bunch of different settings. You definitely don't have to have it at full blast, I think. And then depending on whether you want the decode on or not on, it'll set up the digits appropriately and clear out the display before you get going. So I think that's just nice to have as a function. So now you just call initialize. And so let's just quickly test it. So let's send a command. Digit 4 will send the character A, and then we'll send a 1 to digit 4 in the second display. So first display, second display. We'll look at that for 5 seconds and clear. And then I decided to do a little more sophisticated counter than we did in the last one, where we count from 0 to 9,999, using some of the tricks we've learned in this series on the LED displays. So how to get all the digits, our little trick here for that. And then making sure we clear out any leading zeros. We don't want to display those on our counter. And then sending those digits to the display, and it'll just keep counting until we tell it to stop, and then we'll clear out the display if we do. All right, so let's see this one go. Okay, there's our A and our 1 in the proper places. And here goes our counter. And that seems to be working pretty good. We'll just watch it click over. Okay, it got to the second digit. You'll have to believe me, it gets to all the digits. So feeling pretty accomplished, and now we have some cleaner code that looks a little more professional. Let's take a look at that launch code program that we saw in the last episode, now set up to just use the functions that we put together without using any libraries. Okay, we're finally up to running the missile launch sequence program that we saw in the first episode. So just copying in all the code that we put in the third program there that made it a little more professional and straightforward. So these are all the functions that we discussed previously there, and I'll just scroll past them. And then really there's not a lot of more to talk about the sort of the strategy of the missile launch code program. We talked about that in the first episode where we used the Genesis library to do this. The only thing that changes is just how we're going to get the print code, the final print code that we put together on each loop through, combining, both the random part and the already found part of the code. And now we're just going to try to get that on the display. So it's really these 6 lines of code. We need to address the first display in reverse order. So we can send in the digits in the right way to the display, the way the digits are numbered. So I'm also using, so I'm reversing the code here, and I reverse the part that we need for the first display, and then I reverse the part that we need for the second display. And then to loop over, I'm using the enumerate on that list, so I can also have the index number as well as the character that's in there. So that allows us to have the pair of them together. And you can see when we send the command, we'll use the index as well as the character in the get character function and send the no ops. And then we get to the second display, we'll go through the part of the print code that goes to the second display, and we'll send the no ops to the first display. And again, we're using our index and our character. to get those digits on the second display. And then we'll have a very short delay and make it run. So a lot of work for 6 lines of code to make this work without any ghosting. So hopefully it still works that way. There we go. So we kick it off, searching the display, searching for the code, and no ghosting. It's working appropriately. I'm just so happy to see it work the way it is now. It's very frustrating when I first tried to do this because I thought this wouldn't be that hard. And then it's like, oh, okay, I guess I'm really going to have to learn this chip and figure it out so that I can make it work the way I want. All right, so now this project's, it's moving along now. And so now the next steps for me are to add on a little bit more functionality to this, and then to create some kind of fun enclosure that I can either cut with my laser cutter or 3D print, or maybe some combo of the two. I'm not sure yet. And if I do make some more progress on that project, I will put that together as some episodes so you can see them. But here we are. We've learned how to use one of the displayed driver chips, and without a library, and I think that was very useful to me and really taught me a lot. So I hope you enjoyed going through how I tackled this chip and getting my program to work the way I want. And as always, thank you for watching.